Hello, Math 111 Pre-Algebra Skills for College Success class. My name is Michelle Long. I am your instructor for this course, and this podcast is designed to deliver you some information about Chapter 8, which is all about decimals and percents. For this presentation, we're really going to be focusing on decimals. Your homework is Skill Builder 3.4, which is multiplying decimals, 3.5, which is dividing decimals, and also 3.6 is converting fractions to decimals, and also a little bit of order of operations. So this podcast is going to focus on helping you work through these exercises. In Chapter 8, we're going to be focusing on Section 8.3. Which is multiplying and dividing decimals. And at the end, we're just going to do a little refresher on how to do order of operations and teach you how to do order of operations involving decimals. So here we're going to start out with multiplying decimals. So basically, when you multiply decimals, it's the same thing as you would do when you would just multiply two numbers that were 3 digits. The only thing is that you have to take into consideration the decimal numbers, the decimals in the numbers. So what I did was I laid out the multiplication in a vertical format, and we're going to say what is 0.47 times 0.28. Normally what you would do in a multiplication when you set it up vertically is you would put the number that has the more digits up top and then the one with the less number underneath it. And it's not because you want to align your decimals. You do not have to, I'm going to repeat that, you do not have to align your decimals when you are multiplying decimal numbers. However, you do want to make it so you can perform the multiplication in an accurate way. So in this case, there are 2 digits in each number, so it doesn't matter which one you put on the top and which one that you put underneath. So we're going to go ahead and do the multiplication. So 8 times 7 is 56, bring down the 6, carry the 5, 8 times 4 is 32. You want to make sure and add that 5. Don't forget about that 5, which would make it 37. And then the 0, you don't have to put anything in the line for 0. When you do go down to the second row, when you're multiplying the second number, so for instance, when you're taking that 2 and you're multiplying it by the 47, you want to put a 0 in the first placeholder, and that is actually under 6 here in this particular example, but some do not even put the 0 in, they just leave it blank. But if you feel comfortable putting the 0 in there, so when your columns are set up, there is an actual number in there, you can go ahead and do that. But we're not going to put one in there for this example. So then when you take the 2, you times that by the 7, that's 14. You bring down the 4, you carry the 1, 2 times 4 is 8, plus 1 is 9, 2 times 0 is 0. So they did bring down the 0 there. You don't have to, but you can. Doesn't make any difference. So then what we're going to do is we're going to then do the addition. 376 plus 940 equals 1316. So that is your answer. So then before we stop, before we say, okay, this is our answer, what we're going to do is we're going to take into consideration the amount of decimal places that you have in your original number. So for 0.47, we have 2 decimal places. For 0.28, 2 decimal places, and the way that you calculate the decimal places is from right to left. So how many decimal places do you calculate from right before the 7 to before the 4? So there are 2 decimal places there. 2 decimal places in 0.28. So if we add those together, that gives us a total of 4 decimal places that we have to place in our answer. So since our answer is 1316, we're going to start from the right and we're going to work left, and we're going to say we're going to move the decimal point 4 places to the left. So before the 6 is the first, before the 1 is the second, before the 3 is the third, and then before the 1 is the fourth. So your answer is 0.1316. Here is the same exact thing. is you have 3 decimal places in your first number, you have 2 decimal places in your second. When we multiply them, we get a total of 5. 3 plus 2 is 5 decimal places that we place in our answer starting from right to left. So if we move the decimal point over 5 places to the left, it ends up after the 8. So our answer is 8.00496. Division is a little bit different than multiplication in that we have to look at the divisor whenever we're dividing decimals. The first thing we want to do is we want to take a look at the divisor. In this case, the divisor is 7. Divisor is the number that divides into the dividend. So the dividend is the one that goes in the division symbol. Your answer in a division problem is always the quotient. So if we look at the divisor, which is 7, and it's a whole number, great. We don't have to do any movement of any decimals anywhere. What we do have to do, though, in the answer and the quotient is bring up the decimal point right away. So that's why I have that red arrow there. Before you start doing any computation, bring up your decimal point, because once you start doing your dividing, multiplying, whatever, the decimal point can get lost in the shuffle up there. So just bring it up as a symbol that you're going to put that there first before you start putting your numbers in your quotient. Okay, so what we want to do is we want to take 7 and we want to divide that into 1.806. When we take 7, it obviously does not go into 1. So we're going to put a 0 on top of the 1. Okay, so the next thing we're going to look at is, does 7 go into 18? And yes, it actually does go into 7. It goes into 18 2 times. It goes in a safe amount of times 2 times. Because if we were to say 3, then 3 does not go into 7 does not go into 18 3 times, because 3 times 7 is 21. Then you would be going over 18. Your mission is you do not want to go over the amount that you're dividing into, which is fine that we're using 2, because we're under 18 just enough. So if we say 2 times 7 equals 14, and then we subtract 14 from 8, we get 4, and 4 is less than the divisor, so that's a safe number, number 2. We can use number 2, and that's fine. We don't have to go back to the drawing board and figure out what another number is. So 7 goes into 18 2 times. 2 times 7 is 14. 18 minus 14 is 4. Okay, so we're not finished yet. We still have to finish out our division problem. We're going to bring down the 0. So this way 7 will go into 40, because 7 obviously does not go into 4, so we need some help here. We need to bring down that 0 as help. 7 goes into 40 a safe amount of times 5 times without going over 40. Because if we were to say 6, then we would be going over 40. We would say 7 times 6 is 42. So we're going to say 5. 5 times 7 is 35. When we take 35 and we subtract it from 40, that gives us 5. We're still not done. We still have one more row of one more number to put in our quotient. So here we have 40 minus 35 is 5. We bring down the 6 to make it 56. Does 7 go into 56 an even amount of times? Yes, it goes in 8 times. So we're going to put 8 up in the quotient next to 5. 8 times 7 is 56. 56 minus 56 is 0. Since we have a 0 in our remainder, that makes it a terminating decimal, which means that it can't go on anymore. Kind of like when people pass away, they terminate, they don't go on anymore. It's basically what a division problem does. It terminates. That's where they get the name from. So you can say, what is 7 into 0? And it would ultimately be 0, but you would just continue zeros on infinity. So the answer to this problem is 0.258 is your decimal in this division problem. Okay, here we have another terminating decimal. So before we do any division, we have to look at the divisor. So we remember what the divisor is, right? Because it's the number that goes into the dividend. 16. Does it have any decimals in there? No. So great, we can start performing our division. Before we perform our division, you want to make sure and you want to bring up that decimal in your quotient before you start doing any adding, subtracting, multiplying, dividing, all that fun stuff. Put your decimal in the quotient before you do anything else. Okay, so 16 goes into 0 how many times? 0 times. 16 goes into 0, 0, 0, 0 times. 16 goes into 0, 0, 9, 0, 0, 0 times, because 16 cannot go into 9. However, 16 can go into 92, and it goes in a safe amount of times 5 times. So if you take 5, you times that by 16, that will give you 80. 92 minus 80 is 12. 12 is less than 16, so we're good. With our 5, we can keep it at 5. So to continue on in our division, we cannot take 16 and divide that into 12. So we bring down the 8, because 128 now is divisible by 16, and it's actually divisible by 16 8 times precisely. So here, since 128 minus 128 is 0, that makes it a terminating decimal because we can't go on any further, and our answer is 0.0058. Okay. Here it's asking us to divide 14.56 divided by 3.5. So before we start, if you get this question on a test, the first number is the number that you're actually dividing. So, like for instance, 14.56. If you think about that as a bag of M&Ms, you're going to divide your bag of M&Ms by 3.5, maybe all the yellow. So you're taking all the yellow and you're dividing them up, and you're figuring out how many yellow are in the bag of M&Ms. Well, since 14.56 is like the bag of M&Ms, that's the dividend. That's the number and the bag of stuff that we're going to be dividing out. 3.5 is the divisor. That's the amount of yellow M&Ms that you're dividing. So when we set up our division problem, 14.56 is going inside the division symbol as a dividend, and 3.5 is going outside of the division symbol as the divisor. So before we actually do the dividing, there is a step that we have to think about first before we start doing our dividing. And that is 3.5 is a decimal. We cannot divide when our divisor is in a decimal format. What we want to do is we want to create that 3.5 as a whole number. So if you remember, all whole numbers have decimal points to the right of them. So in order for us to make 3.5 a whole number, we have to move that decimal point, which is before the 5, to after the 5, which will then give us a whole number, which is 35. So we're going to go ahead and we're going to put that 35 as our divisor. So the movement is already done. Our dividend has to reflect what we do in our divisor. So since we've moved the decimal point one time over to the right in our divisor, we have to do that also in our dividend as well. So in our dividend is 14.56. If we move that decimal point before the 5 one time over to the right, it's going to place it before the 6. Okay, so let's go ahead and put that in the dividend. 145.6 now as our dividend. So we can now do our dividing. Okay, but remember also, before we do any dividing, we have to bring that decimal up to the quotient. So we're going to go ahead and do that so it's written in stone as where that decimal point is and we can't move it around. Okay, so let's go ahead and start our division. So 35 goes into 145.60. How many times? We don't know. So we're going to start kind of breaking it up here in order for us to find out how we can do this division. So we know that 35 does not go into 1. It does not go into 14. but 35 definitely goes into 145, but we don't know how many times, and we can guess off the top of our head. So there's two ways that we can do this to figure out how many times 35 goes into 145. We can take the 3 and we can measure to see how many times it goes into 14. So it's a little bit easier to try to figure out how many times 3 goes into 14 rather than 35 go into 145, because we have to start getting our calculator out. We have to start doing some manual multiplication. So to make it easier, we can say, well, 3 goes into 14 4 times. Let's go ahead and try 4. Well, as you see over on the right-hand side there, we did some multiplication to see if we would be under the 145 if we did actually multiply 4. So 35 times 4 is 140, which is actually perfect. Because if we were to say 35 times 6, 210 is more than 145. If we were to guess and say 35 times 7 is 245, that's way over the 145, so we can't use that. But we can use 4 because 140 is under 145. So let's go ahead and say 4 times 35 is 140. Now if we take the 140 and subtract it by 145, that gives us 5. Okay, so we want to continue our division. So 35 does not go into 5, so we'll bring down the 6, because 35 does go into 56 and it goes in 1 time. 1 times 35 is 35. When we subtract 35 from 56, we get 21. When we bring down our 0, that gives us 210, which will be divided by 35. And you can see over on the right hand side there our doodling. When we took the 35 and start multiplying that back earlier in our problem, we actually do see from our doodling that we already did figure out how many times 35 goes into 210. It goes in 6 times. So let's go ahead and put 6 in our quotient next to 1. 6 times 35 is 210. 210 minus 210 is 0, and it terminates to after the 6. Therefore, our answer is going to be 4.16. Okay, so far we've learned about in the previous podcast how to convert a fraction to a decimal when the denominator is a power of 10. It's a real quick, easy process. It's a shortcut. Hello? So here what we're going to do is we're going to take a fraction and we're going to convert it to a decimal. Okay, it's not quite as easy since our denominator is not a power of 10, but what we do have to do, the first thing that we have to do is we have to take the denominator, we have to divide that into the numerator. So our numerator becomes our dividend that goes inside the division symbol. Then 16 becomes our divisor, the number that we're dividing into. And I know it seems kind of funny because 5 is less than 16. You would think it would be the other way around, but it's actually not. And I'll tell you why. When 5 becomes the dividend, since 16 does not go into 5, what we're going to do is we're going to add zeros to the end of it. But if you remember, all whole numbers have a decimal point at the end of it. We don't actually say that or write that formally, but in reality that's actually what is happening. So since 5 is a whole number, the decimal point is going to go after that. Sometimes your numerator can be a decimal number with a decimal in it, but that would become the dividend, and you would, your decimal would be there. But since this is a whole number, the decimal point goes after, and then if you remember, anytime zeros are added after a decimal number, it's no value to the number, none, doesn't change it at all. So for the computation of this division, we're going to add those zeros there so we can come up with a decimal number for our conversion. 16 goes into 5 0 amount of times. Oh, also before I start my computation, also remember to bring that decimal point up in the quotient. Cannot forget about that. So 16 does go into 50, it goes in 3 times. 3 times 16 is 48. When we subtract 50 minus 48, we get 2. We bring down the 0. How many times does 16 go into 20? 1 time. 1 times 16 is 16. 20 minus 16 is 4. Bring down the 0. We have one more 0 after this. 16 goes into 40 2 times. 2 times 16 is 32. 32 subtracted from 40 is 8. We bring down the last 0 in our dividend. 16 goes into 80 how many times? 5 times. 5 times 16 is 80. 80 minus 80 is 0. This is terminating, therefore we have an actual number, an actual decimal number for our answer, and 5 over 16 equivalent decimal is 0.3125. Here is the same thing. You can see that 11 becomes the dividend, 80 becomes the divisor. And we don't have any moving of any decimals because 80 is our divisor and it's a whole number, so that's fine. We just leave the dividend the way it is. We do put the decimal point after the 11 and we add as many zeros as we want. We can add 20 zeros if we want to, but if it terminates, there's no need to add any more zeros after that. And after we do the division, the computation, and place our decimal point up in the quotient, our answer then becomes 0.1375. So the 11 over 80 is as a fraction. The equivalent decimal is 0.1375. Okay, so here we are going to take 2 and 11/18 and convert it to a decimal. So for us to do our computation to figure out what our decimal number is, we're just going to ignore the 2. So just put your finger over 2. When you put your finger over 2, we're looking at 11 over 18. That's the only thing that we're focusing on here. So just like in the last 2 slides, we're going to do the same thing here. 11.000 is going to be divided by 18. When we do that division, it's going to come out to 0.611. If we continue to keep dividing and finding a quotient and keep going and going and going because we're not terminating, it would ultimately be 0.6111111 eternity, forever and ever and ever. It would just be 1, 1, 1. So instead of sitting there writing 1,000 ones, what you can do is put a little line. It's a little vertical line over top of the number and only the number that repeats. So if you see your decimal number in the answer at 0.61, the line goes over the 1 because that is the number that just keeps repeating. That's an indication telling everybody that 1 just keeps continuing. It just continues on and on. Okay, so take your finger off the 2. And if you remember from our previous podcast, anything to the left of a decimal point is a whole number. 2, because it's a whole number, and the mixed number, 11 over 18. The fraction part of that mixed number converts to the decimal number. 2 is the whole number. So then what we do is just bring over the 2 and put that in the whole number slot. 2 and 11/18, convert it to an equivalent decimal as 2.61, where the 1 is repeating. Same thing here. I don't really need to go over this because it's basically the same type of philosophy as the last 3 slides, but you're taking the 28, dividing it by 27, you're come out to 1.037037. So if you notice that if you were to continue on, because it's not terminating, if you look down on the bottom of the division problem, you get 190. That's not 0, so it's not terminating. But if you continue on and keep dividing on and on and on and on and on, you will keep getting 037, 037, 037, 037. So notice that since these are the numbers that are repeating and they keep repeating, we're going to put a little vertical line over those 3 numbers. Make sure that when you do use that vertical line in your division and your answer, that you're only putting the line over the number or numbers that repeat. Okay, just a little refresher from back when we were learning order of operations a few chapters ago. We're going to now be applying order of operations to decimals, and it's the same thing. Nothing ever changes. It's always going to be PEMDAS. Please excuse my dear Aunt Sally. It's parentheses, exponents, multiplication, division in the same bubble, and addition, subtraction in the same bubble. So let's continue. If you look on your Skill Builder 3.6, which is one of your homework assignments, I'm actually going to be doing number 10 on there. So I'll be going through it with you and I'll be giving you the answer. So this way when you do number 11 and you do number 12, you will have this exercise and training on this one here, so you'll be able to perform the next two order of operations. Order of operations can be complex because you're dealing with a lot of things, a lot of different steps. You're dealing with a lot of different mathematic symbols, expressions. It can get really complicated, it can get really long. So basically when you are working with order of operations, you want to do it by a step-by-step format. And I know, and I say this all the time, how tedious it is to do one thing at a time, go to the next line. One thing at a time, go to the next line. We are so brainwashed in our daily, day-to-day life that we have to multitask and do 50 million things at one time that order of operations is actually the complete opposite of that. So take that out of your brain about doing the multitasking, because this is actually the opposite. With this problem, it is asking us to divide 15 to 0.3, subtract 175, and then divide the answer to 3.21 plus 1.79, but squared. Okay, so just think about this problem and what we're doing here. We're dividing, subtracting, dividing, adding, and finding the square of decimals and whole numbers. So in a nutshell, it's basically what we're doing here. We have to figure out what we have to do first. What do we have to do first? Okay. Well, typically, you know, how we're trained in our daily lives is, well, we do the first things first, and then we go to the next thing, and then we go to the next thing. Well, order of operations is completely different than that. You want to try to move away from that. It's called order of operations, called order for a reason, because there's a particular order to doing this. And the first thing that we're looking at is parentheses. So we scan our expression and we see what's in parentheses first before we do anything else. We even ignore the exponent for now because we're only looking at what's inside the parentheses. So I have a little arrow there pointing to what's inside the parentheses to tell us that's the first thing that we need to do. Okay, well, what is it asking us to do? It's asking us to add 3.21 plus 1.79. Okay, so we go get our calculator, or we do it manually. We add them together and we get 5. 5 is our answer. Okay, let's keep looking to see if there are any more parentheses. No, there are not. The only parenthesis we have is a 5, but there's nothing other than the 5 in there, so we can move on. The next thing it's asking us to do is let's look at any exponents in the problem before we even think about looking at any multiplication or division or addition and subtraction. We need to figure out the exponent first. Okay, so first things first. When we take 5 to the 2 power, or 5 squared, is 5 times 5. And 5 times 5 is 25. So we're going to replace the 5 squared in the problem with 25, and we're going to rewrite it. Okay, so the next line is 15 divided by 0.3 minus 175 divided by the 25 that we got in our last problem. Okay, so let's figure out now what we're going to do next. Well, the next thing that we do is multiplication and division, and they're bulked together. And the reason why they're bulked together is because when you scan an expression from left to right, you have to figure out what is first. Is multiplication first? Is division first? Whatever first expression of multiplication and or division that we come up with first, that we see first, that is what we do. That's why I underline 15 divided by 0.3. Okay, so in the next line, after we do our division, it comes out to be 50. Bring down the rest of the problem. Minus 175 divided by 25. Okay, we're still in multiplication and division mode here because we have not completed all of the multiplication and division in this problem yet, and we're going to go ahead and do that. That's why I have the arrow pointing to our next expression. So multiplication and or division starting from left to right, we're going to scan it. Yes, we come up with 175 divided by 25. We do our computation and we come up with 7. So 175 divided by 25 is 7. We're left with now addition, any addition and subtraction in the problem that's left. Well, we don't have any addition. The only thing we do have is subtraction, which is 50 minus 7, and our answer is 43. So I would advise to look at this order of operations 5 to 10 times if you have to, because order of operations can get very, very tricky. My advice is, and my strong recommendation is, to do one thing at a time. Do one expression and complete that. Move to the next line, rewrite everything. Bring down everything from the right of that expression to the left of that. Work on the next thing. Focus on the next thing you have to work on. Bring it down. Just keep bringing it down, down, down. It's the most accurate way that you can get your answer. Because if you're doing more than one thing on one line, it can get very confusing. The end. Okay. Any questions? Any reason why you feel like you want to meet with me for tutoring? I'd be more than happy to do that. You can send me an email, or we can Skype. So I look forward to hearing from you if need be. If not, good luck on your homework assignments. I hope that this has helped you.